good afternoon to all of you guys. How are you doing? I trust you are very good. And then I would just want to invite you in. If you have watched some of my previous videos, you would have seen my videos on how to crack web, how to actually do a number of things, bypass various authentication protocols within web. Actually, the whole idea has to do with my thesis work on vulnerability analysis in local area networks, which I've already discussed in some of my previous videos. Now in today's video, we want to build a series with the EAP method. So basically, I'm interested in looking at the third type of protocol for Wi-Fi. So if you grab a copy of my thesis work, you will find that within this topology, with WPA or WPA2 Enterprise Edition, where basically the security protocol is outsourced to a third-party server, which will be running, let's say, radius or basically diameter. Okay, so when a client wants to basically associate with a wireless network, it sends an authentication request to the AP. All right, and then the AP relays the information to the authentication server, because all the AAA require authentication, authorization, accounting sits on the authentication server. So it's on the authentication server that we have that, for example, the client is authorized to use the network. What is the username or information of the client? Everything stored here. So the access point has nothing compared to security. All he does is to relay all information to the authentication server. Once the authentication server basically grants the client access to the network, that you're authorized to use the network, straight up the access point would forward the information to the victim. And then once the victim is authorized, the connection is taken between the access point and victim, and then from there the client can basically hit the internet without not going through authentication again. So this actually happens in most telecommunication companies. For example, broadband services or what have you, there's always a radio server whose responsibility is supposed to be for authentication. In most scenarios in telecommunication network, they prefer to use the BRAS. Basically is the same thing. All that we're just saying here is that based on this research, we are going to compromise this authentication server, and then we're able to eavesdrop on the communication that is moving here, and then we're able to hack into the authentication server. That is the goal of the research. This same scenario, perhaps some research can extend it to BRAS and all those kind of things in the telecommunication world. I'm sure they are also hackable through this same similar process. All right, good. So quickly, let's just look at the handshake. Let's just review. I already talked about that. So we go here to the okay, EAP over LAN, which are fully captured right here. So the first procedure is for the hold on. Right, good. Okay, so basically in the enterprise edition, what happens is that first the client has to basically send an EPO start message that I want to negotiate EPO with you, and then this EPO is extensible authentication protocol over LAN. Alright, so within this frame is going to carry the various security credentials that the client basically support. As soon as the authenticator receives this, it's going to ask the supplicant to actually send its credentials like username and password to the network that the client has. So the client basically will reply to this identity with the identity response message. At this stage, because the authenticator cannot check whether the client is authorized or not, because that function has been relayed to this third party, all that the authentication will do is to forward that information to the authentication server. The authentication server will basically go through its protocols, look at the security credentials that the client is supplying, and if it's satisfied with that, basically it will like to create a challenge depending on what EAP method we are doing, whether we are doing EAP, MD5, PEEP, what have you. All right, MS-Chat V2 handshake, it can actually take place once this challenge message is sent to the is forwarded basically to the client. What the client has to do, he has to respond to this challenge message. In most scenarios, the challenge message is something that he has to do an encryption over it and then forward it back, and then once he responds to that challenge message, the AP relays it back to the AP. As soon as the AP looks at it, the response to the challenge message, and then it's exact and correct. And if you go through my thesis work, I have shown you the details of actually the exchange, the response messages, and for functions like MD5 or PEEP, what are all these features are fully explained. So either at this stage, the authenticator will now grant him either an accept or reject message will be forwarded basically to the AP. If it's successful, then the various protocols will now run, such as the installation, the PTK, GTK between the AP and then the supplicant, which does not require this, will now take place. And then from there, key installation goes through and the encrypted database guide goes through. Alright, so this is very, very simple. So first of all, hold on. Okay guys, so welcome back. So that is that. So in this video, what we're going to do is that we're going to build this authentication. You know, it's very costly to have an authentication server, but what happens is that BackTrack comes with an inbuilt authentication server, so that you can actually simulate the EAP protocol and then be able to do the various attacks on EAP protocol, which we are going to do. So what I'm basically going to show here is to show you how to configure BackTrack to behave as an authentication server. And then the utility in BackTrack is actually the free radius. So if you do read on my research, I've captured it clearly here, the various procedure to actually go through the free radius. So bear with me, let's do that. So number one, what we basically do is we have to open our VM. So we actually start our BackTrack VM and then we start it up, let it boot up, and then also the access points. I have the access point basically here. It's a very small access point. Alright, so over this access point, what you just do is to connect the LAN cable from here, alright, and then all the way to the USB of your laptop. Right, so I have my laptop fully configured here, connected to the USB, so that we're going to do the various EAP settings on these access points. Alright, okay, so this is just procedure, enter, and then we start in the BackTrack. In the same way, let's open the Explorer so that we can go into the interface of our wireless of our access point. So 192.168.0.254, that is my access point, and then that is my interface, right? The funny thing about some of these access points that they come in with their login security credentials are not changed, and it's a very bad thing. Someone gets into your access point and then use the default login configurations, login systems, you'll be in trouble. You can always go here to actually do the various changes. Okay, good. So now let us come here. Now that we've configured the access point, let's go into wireless, and then we do wireless security. So wireless security, what we are trying testing, we are going to test this particular protocol here. Okay, so let's see if our access point is up and running. Okay, so we go into the graphical interface. I've already explained this in our previous video. So start X, then basically the interface will load up. Okay, so basically for the access point, all we have to do here, we can leave it to choose because we are doing EAP enterprise. The encryption, we can leave that as well. It will depend on what encryption protocol is going to receive from the authentication server. This one is likely to change. Okay, so we hold on to that, and then the radius test file also maybe changes, so hold on to that. Okay, so our BackTrack is currently up. So basically what we have to do is that we have to go into a console interface, and then we have to configure our Ethernet ports. We have to configure, so the command as usual is ifconfig, so you can see our interfaces. ETH0 is a physical Ethernet port, which the Ethernet port where we connected the RJ45 to the alpha card. Okay, that is this port, right? So now for this, and then this is basically a loopback interface, and then Y-line 0, you know, is because of our alpha card, that is the port connected. So now for our ETH0, that is the physical port facing the access point. Okay, now because we have to create a physical connection between the, come here, we have to create a physical connection, right, through an Ethernet port from this access point to our server, and this server is sitting on our laptop. That is why we are connecting the RJ45 to our laptop. When we connect it to the laptop, now this server has DHCP on it, right? So what we are going to do is that it has DHCP configured on it to release IP address from 100 to 199. Okay, so in all it has 120 IPs. So what we are going to configure here is that we are going to get this. We are basically going to get the card to actually request for DHCP from this access point. Okay, so I can get a point-to-point IP on the interface. I hope it's clear. So that this guy will have an IP, and there's going to be an IP here also sits on our interface. Okay, now if we come here and then get into our alpha card here, we now have to go into networks, and then basically to choose bridging. So we will be bridging it with our Ethernet adapter, which is the gigabit internet interface. Okay, then we're going to apply. Right, good. So now once we've applied, we can lower that, and then we can come here and then run the DHCP client. Okay, client 3, and then basically do ETH0. So ETH0 is the interface that we want to request for DHCP. So once we enter, it will start sending and then basically requesting for DHCP, and then holla, there we are. It has successfully allocated. It has successfully requested. BackTrack has successfully requested for an IP address from the access point, which is going to use to connect to the radio server which comes within the BackTrack. Alright, good. So now if we repeat the ifconfig, you should be able to find an IP address on ETH0, and there we are. ETH0 now has this IP, which is the 192.168.0.100, which he has requested through DHCP. Alright, okay, good. Now this is going to be the IP of the DHCP server, and we have to input this IP into the access point list of wireless networks. So we just come here to wireless security, then basically the IP address we had through DHCP, let's confirm that again. It was 100. Okay, so once the access point gave us 100, so we have to enter this 192.0.100, that is interface IP, right? Then next is this radius password. Now the radius password is a password that is shared between the access point and then the authentication server. so that the access point can authenticate itself to the authentication server, and the authentication server can in turn authenticate itself to the access point, right? However, so that at least there will not be any rogue access point connecting to the authentication server. However, during our thesis work or during our research, we found out that this credential, which is the username and password, which is stored on both access points and then the authentication server, is clear text. Because if you go into the configuration file for the authentication server, which I'll show you, you realize that the username and password is clear, it's not encrypted. There is no sort of encryption between these two guys. So if you have a backdoor, you can get inside and get all the username and password which is used to authenticate between the access point and authentication server. Subsequently, you can bring up your own access point and then you can request using the same authentication rights, and then you will basically enter. Alright, good. So let's come back here. Okay, so we go here to input this IP into this place as well. We've inputted that. Now let's use password. Like, what do you think? Password between the access point and that. We can decide to use, what do you think, radius, what radius 1 2 3 4. Fine, that's fine. So this same password needs to be configured within the authentication server so that they can basically exchange. Alright, okay, so this is basically all, and then what you can just do is to save that, and then after saving, it will require you that you should basically do a reboot so that it can basically take place. So you choose reboot, and then the access point will basically reboot, and then once it is finished rebooting, we will basically be done with all the configuration required for WPA EAP. Then after that, we will set the same username and passwords within BackTrack, and then that will we will finish setting the authentication server on the BackTrack as well. Okay, 46% is still rebooting. We can pause this video, and then once we finish rebooting, we can just come back. Alright, welcome back. So basically it's finished rebooting, and then if we go and check on our security, it should now support WPA2, and then with the password also right here. So here you can see that if anybody has access to your IP address, right, and then he finds a way to connect to your access point, and then he just go in, and then most of these access points are using a default password. Default, some are doing root, admin root. This password, you can just go onto the internet and then just type commonly used password on access point. If you use TP link, they are there, the default password. So normally it's advisable that when you get access point, you really have to change the settings. After this, I'll show you where to go to change those kind of settings. Okay, good. So we are done with this. So now let's configure BackTrack to support the radius authentication server. Okay, so basically what we'll do here is very simple. We first go to the file manager, okay, and then you choose root. Then what you have is USR. You go here, USR, you choose local, you choose etc. From etc you choose this is actually the file that contains the radio server, okay, the radio server software and all the algorithms in the program. Alright, so you open this up, and then once you open this, there you are with the interface. Okay, so the first thing is that now remember that every EAP method basically supports a type of EAP, which we've actually explained in our thesis work. If you do come to the various EAP methods, EAP authentication methods basically explained here, you can find this in INA, and then you can see the various value for is MD5 challenge, which is RFC 3748, and number of EAP methods that are actually acceptable. this pip is there, EAP TLS, and then I did explain in my my videos on WPA, EAP, EPO, handshake, that these protocols are a form of up to layer 4 protocol, which creates the tunnel so that it becomes like server client architecture. Alright, certificate exchange, digital certificate exchange, and all that for EAP TLS, so that it can be used to serve as a tunnel, okay, as a tunnel, as a VPN, something like a VPN tunnel between the authentication server and then the authenticator, so that the various challenge and response message that will go between the authenticator and authenticated server can actually be protected from activity. Right? Okay. However, I have explained to you that this secure tunnel called PIP or EAPT TLS, or what have MD5, is actually is hackable. There's a way you can hack into it, and then you will receive all the inner authentication protocol which EAPT TLS or PIP is trying to basically protect, and then based on that you can use that to recover the encryption, the network key, so that you can actually hack into the EAP or the enterprise network. Right? You do know that most of these enterprise networks are basically used by banks and large organizations who cannot store the user credentials on an access point, so they just relay to a third party. Okay, I would love you actually take a look at my thesis work, and then you'll be lovely at the various things that you are going to learn. Okay, good. So first of all, once we've opened the EAP config file, which we actually did by just double clicking that, all that we just do is we come here to the default EAP type and the EAP method that we basically want to do. For example, we want to do MD5, we actually just type MD5 in there, and then we are basically done. So the various EAP methods, it can be PIP, right? You can see the various, it can be LIP MD5, can be GTC, can be TLS, it can be TTLS, it can be PIP, various PIP, it can be MS-chat v2, what are the various protocols that can basically support. So for now, let's just do MD5. Right? So basically this is all you have to do within this file. Once you've done that, remember to save. Just choose on save, and then the file is basically saved for you. Alright, so you can basically close that. Next, we now have to configure the user credential between the radio server and then the authentication server. That file within BackTrack 5 is actually the client config file. So when you open the client config file, scroll down to the last part of it. We are there at the last part, and then you search for the IP block that is serving the network we have, and then remember that within here our IP block, if you do go to a DHCP, we are within this 192 range, and then basically our client connections here, and then basically our client connections are also within that same range. So if we go back here, realize that this is actually the block which is for us. So the secret key is basically what we talking about, and then we choose let's confirm radius 1 2 3 4. Make sure it's the same, it's case sensitive as well. So we're going to compare this with basically what we chose in the access point. Wireless security, and then yeah, they are basically the same here. So now you have that, you can just choose save. Alright, then you can close that as well. Okay, so here you are, you finish saving, and then once you've done this, you realize that a new additional file is basically created. It's nothing. So to start this radio server, from our lab setup, I've actually explained the various steps that you basically go through to do the configuration here for you. Okay, so basically to start the radio server, which we know to be this server, power on the radio server. In BackTrack, the command is very simple to start this radio server. Just open any console interface. I just choose console from here, right? Console, and then all you have to do is to type RDIUS radius D, alright, and then with a small x you can actually enter to see the various parameters. Sorry. Okay, so radius D dash x and then dash capital S starts, and then basically this is going to actually start. Oh, I didn't type this thing well, did I? Okay, just come in. Gotten a call. Sometimes syntax be some way. It looks like I exchanged them, right? It's dash s dash x rather. So let's go back here. I rather the thing. Alright, so it's actually radius D dash s and then basically dash big X. Okay, and then that is that. So with this, our radio server is started, and then you can see the various protocol. It has the various logs set up to actually accept any logs. It will keep that. In terms of security, it has the security attributes set, and then we have that. So my brothers, this is all that you require to set up a radio server. And then once the radio server is now set, we can now go ahead and then connect a client to this access point. Okay, and then the access point will basically relay all the information which is basically happening to this radio server that we have actually set up. Alright, so it will just start to relay all the various information to this radio server that we have actually set up within BackTrack. So my brothers, this is the cheapest way to basically know about setting authentication server within your laptop, alright, using BackTrack 5. Thank you so much. God bless you. See my next video where I actually introduce you more to the various security protocols and then the various activities. Thank you. Once more, my name is Akomea-Agyin. I'm basically from Ghana, and I'm doing these nice videos basically for you, alright, to understand security protocol. Okay, bye.